Hi, everyone. My name is Laura DeNardis, an internet governance scholar and a professor and endowed chair in tech, ethics, and society at Georgetown University. I'm delighted to join you at the Space Summit to discuss solar system internet governance. Is it too soon to think about a solar system internet, never mind its governance? History would tell us no. The internet has only recently turned 50 if you view its inception as the late 1960s American milestone of the first packets exchanged among ARPANET nodes. The founders of Google and Facebook were not yet born, and NASA was still preparing the Apollo 11 mission to attempt the first lunar landing in history. This happened in my brief lifetime. Since then, the pace of technology has been stunning, and the internet has diffused around the Earth, around our planet's atmosphere, and into material objects and even into the body. So it is not too soon to think about interplanetary internet architecture and governance. The stakes of internet governance in general are very high. A quick flashback to a book that I published around a decade ago called The Global War for Internet Governance. The opening paragraph has come true in every possible way, I'm afraid, and that is that internet governance conflicts are the new spaces where political and economic power is unfolding in the 21st century. Now, by internet governance, I mean the administration and the design of the technologies that keep the internet operational and the enactment of policy around these technologies. A few quick points about this. First, it is about design and technical coordination as much as it is about policies and regulations about the systems once they're developed. Second, there is not one issue called internet governance, but rather numerous functions from standard setting to the administration of critical internet resources to private interconnection agreements, cybersecurity governance, and also government regulatory structures. And third, the term internet governance is an oxymoron because it is not just about governments. The various functions establishing policies around the internet are distributed across many different actors, which is why it's normally called the multi-stakeholder governance framework for the internet. Now, one thing that we've seen over the years is that technical infrastructure is highly politicized in this domain, and it has become a proxy in many ways for surveillance, for censorship, for disruption, and private and public power in various ways. This will likely continue in the internet's next chapter, which lies in both infinitesimally small and astronomically large spaces. It is in these large spaces that I've recently done some projects. I published a paper on interplanetary internet governance with the Center for International Governance Innovation, or CIGI. I was part of the team that published the Interplanetary Networking Special Interest Group report about solar system internet architecture and governance with the Internet Society. And I was part of the independent task force on securing space at the Council on Foreign Relations. And we just launched our report called Securing Space, a Plan for U.S. Action. Two of these projects address long-term issues, and one involves the present moment. But I want to ask a question here. What is it that we're talking about when we talk about space networks? This is actually a very diverse area. There are already thousands of low Earth orbit satellites. In low Earth orbit alone, which is about up to 1,200 miles, Starlink's constellation has around 7,000 satellites with a planned rise to more than 40,000. And you're probably also aware that the International Space Station is in low orbit, actually a very low orbit at about 250 miles, I believe. Medium Earth orbit includes critical global navigation satellites, including the extremely important GPS system. Geosynchronous orbit, these are satellites at an altitude in which their orbital speed exactly matches the Earth's rotation. So they're positionally fixed relative to the Earth. And they're used for many different things: weather monitoring, navigation, military and intelligence functions, and also broadcast TV like DirecTV. So there are many other networks, moon networks, things in cislunar space, meaning between the Earth and the moon. And there's also the deep space network of powerful ground-based antennas that provide point-to-point communication with between the Earth and spacecraft. Much more future-looking is the solar system internet, or if you want to call it an interplanetary internet. This is more of a general purpose store and forward packet switched designed system that would connect many nodes and many networks with the intention of supporting exploration, communication, and discovery. All of these have multiple segments. They have to be secured. They have ground segments. They have space segments, link, and also user segments. So it's a diverse area. Why do these networks matter? That's easy to answer. Human exploration and discovery in space is entirely dependent upon communication systems, but possibly even more importantly, everything on Earth now depends on space. Our strategic dependency on satellites here on Earth cannot be overstated. A disruption in space would be a disruption of transportation, financial transactions, weather, internet access, among many other systems. So then, of course, includes the stock market and anything that relies on time synchronization, precision timing, such as time stamping for every trade. We have an economic dependency on space. We have a social dependency on space. And we certainly have a national security dependency on space. It is an operational domain for NATO. Space is a domain of warfare in the US, with the US Space Force now the military branch tasked with protecting American interests in space. So that is very important, but so too will the solar system internet be important for humanity. Amazingly, internet pioneer Vint Cerf was already broaching the subject of an interplanetary internet at an Internet Society meeting back in 1998 when he had an appointment at the Jet Propulsion Laboratory. This is quite a remarkable vision in the time before most modern internet applications. One way to think about the difference between this and some of the existing networks is that while more near-Earth space networks often involve point-to-point communication between Earth and a spacecraft, the solar system internet would be more of a packet switched network, a mesh network that connects many different networks and many different nodes. It may not be possible yet, similar to the early ARPANET, to envision the uses of such a network, but it certainly would support discovery and exploration. It would support space stations, commercial uses, human space travel, and inevitably many national security and intelligence applications. How do you think about the governance of something that is in development? This is a question of anticipatory governance. What governance functions, we can't really use the word geopolitical, maybe what heliopolitical frameworks will be necessary to design, administer, and secure an interplanetary network for the benefit of all? We can probably break that down into many questions. I have 4 here. One question is about the unique constraints of space that will shape its design and governance. Another question that I'll address is about the existing space governance context. What are the treaties and frameworks that now exist, and are they at all relevant to modern information and communication technologies? The third question is about the applicability of Earth or terrestrial internet governance functions to space. What might be the same? What might be different? And finally, what lessons from Earth internet governance can help inform the structures of interplanetary internet governance and some of the challenges that we may encounter? There really are many interesting and important constraints and contexts in space that shape governance in this domain. Most obviously is the astronomical distances for transmission. This is a constraint that it requires solutions to the latency, it requires solutions to packet loss, and greater autonomy and local processing at nodes. So that is one major difference. This kind of latency and the technical challenges around it, they're a challenge to implementing how many things work in the internet, like end-to-end encryption, performing error checking, even the domain name system and things that require queries back and forth. That is not that realistic over astronomical distances, so it requires re-engineering. Natural disruptions, as you can imagine, are a factor. Solar flares, space weather, asteroids, and harsh atmospheric conditions in space require a great deal more of technical resiliency and stability. Planetary motion is a factor for designing a future solar system internet. The movement of the planets and satellites will create constantly changing transmission distances and intermittent disruptions. As an engineer, I find these problems to be really exciting, but also concerning. Another one is just about the constrained resources. These nodes will require efficient power, renewable resources. They're resource constrained nodes. You can't just go out there and send someone to do some maintenance once it's launched. It's very difficult. So that requires a different approach as well. Time synchronization and time inconsistencies is another interesting issue. Coordination between computing devices requires precision time synchronization. But this time synchronization is challenged by time relativity, such as different gravitational conditions affecting clock speed. So this is a big challenge too. On the governance side, sovereignty is completely upended. This is already disrupted in many ways on the Earth by the way that networks cross borders and by the privatization of governance. But the absence of territorial boundaries altogether in space will challenge sovereignty and tech jurisdiction and really require negotiation and cooperation in a way that is different from the terrestrial internet. And then contention over satellite orbital positions is a rising constraint. This space within space could become a scarce resource, just like there are scarce resources on Earth. There are two more issues, congestion and space debris, that are rising problems. I want to say a little bit about these. It's easy to understand why they are unique constraints. How do you explain the space debris that we have out there? There's a lot of space debris in space. One reason is because in 2021, Russia shot down a Soviet-era satellite that had been launched in 1982. While the first concern of a direct ascent anti-satellite or ASAT missile test may be a national security one, there's another concern. The U.S. Space Surveillance Network identified more than 1,500 trackable pieces of fragments from the breakup. This is potentially catastrophic for the space economy. 2 months later, after this ASAT test, China announced that a Chinese satellite experienced a near miss with one of these fragments. The Chinese government itself had previously conducted a ballistic test, resulting in a massive space debris field. Their 2007 ASAT test hit an old Chinese meteorological satellite. The US and India have also in the past conducted direct ascent ASAT missile tests. So it is not so much the size of the fragment, but the speed that poses danger. A piece of debris that was described as the size of a small paint fleck hit the International Space Station in 2016, causing a 7-millimeter window chip. So even debris the size of a human hair presents risks when it's moving that quickly. So this is definitely a growing problem. What this means is that disruptions have to be anticipated and addressed in fault-tolerant approaches, in resiliency, in redundancy, in very strong error detection and correction, but also political and industry attention to both tracking and preventing ASAT missile launches in the first place. Congestion is, as you can just immediately see from this chart, this is a major issue as well. It's a major constraint. The number of actors launching objects into space has exploded. More than 90 countries now have assets in space. And the overall number you can just see from this chart, it's quadrupled from 2019 to 2023. It says space traffic management is a significant need. This is only going to increase. A lot of this is highly privatized. It's a critical issue to deal with congestion in space. Is there any cooperation at all? Is there international overspace of space traffic at the crowded LEO or low Earth orbit level? The ITU does allocate frequencies and orbital slots in geosynchronous orbit and frequencies for low Earth orbit, but this is a very congested area at other levels of space and really a governance issue that I wanted to mention that probably will carry over into, further into space as networks are built. The next question has to do with what kind of space governance frameworks exist. And there actually are, there are a constellation of laws, treaties, and alliances, many of which arose in the context of last century's space race between the US and the former Soviet Union. In that Cold War context, very few nations had any programs for space exploration. The Soviet Union launched Sputnik in 1957. The United Nations Office for Outer Space Affairs was formed the following year in 1958, the UN's USHA, as it's called. Their Committee on the Peaceful Uses of Outer Space, that's the UN Forum for International Treaties and Principles on Space-Related Activity. So I've just included in this slide so that you can see it, the 5 foundational UN space treaties. The main one is the Outer Space Treaty from 1967 that indicates that space exploration and use should be for the benefit of all. It should be open for all states for exploration and not subject to sovereign appropriation. Importantly, states also agree to not place nuclear weapons and other weapons of mass destruction in space and to use the moon and planets for peaceful purposes. This was originally signed by the US, the UK, and the Soviet Union, but more than 100 countries have since become parties to the treaty. These other agreements include the Rescue Agreement, the Space Liability Convention, which is about international liability for damage caused by space objects, the Registration Convention, which is essentially a tracking agreement requiring within nations registration of objects launched into outer space for various purposes. And then the Moon Agreement, which was entered into force in 1984, laying out numerous provisions about the moon. But notably, the treaty has not been signed by any of the major human spaceflight countries, including the US, Russia, or China. So interest in the treaties, I guess you can say, has waned as space politics has changed. This is a very brief snapshot, but the real question for this talk is, how does any of this apply to the modern cyber domain? Through the lens of internet governance, these treaties are not easily applicable. They predate most internet technologies, including the web, and they do not overtly address information and communication technologies at all. They also predate mass satellite proliferation and our strategic dependency on satellites here on Earth. They also predate Earth national security dependency on space systems, including real-time monitoring and command and control networks. And they are multilateral, not multi-stakeholder, naturally focusing on nation states only and not private actors. This is not surprising because the treaties, they're treaties, but they also predated commercial space programs. It's important to note that there are also a number of non-binding international agreements that have emerged in the contemporary moment. The Artemis Accords, initiated by partners in the Artemis program to return astronauts to the lunar surface, outlines a set of principles and commitments for the peaceful exploration of outer space. Interestingly, this accord actually has a section on interoperability. It mentions communication technologies, and this is very notable. More than 50 countries have signed. I don't believe China and Russia, but this Artemis Accord does include clauses about peaceful purposes, about transparency, mutual assistance, and for the purposes of this talk, most importantly, interoperability. So what more can be done to secure this domain given the strategic importance? I think I would just say that in the near term, or even the current situation, you could summarize it as follows. Space is a critical strategic domain, but one that is vulnerable, increasingly competitive, congested, highly privatized, and not subject to clear rules or even norms. I mention this because what happens with space governance in the near term will shape the governance of the internet that moves into the solar system. So it's highly relevant. Here are some short-term decision points that might shape long-term governance. One question is whether, and I'm coming to you from Washington, D.C., so I'll use the U.S. example. Should the U.S. Designate space as critical infrastructure? Should space assets be designated the 17th U.S. critical infrastructure sector? Our strategic dependency on satellites is considerable. Space assets are vulnerable to cyber attacks, to directed energy weapons, to space robots, to anti-satellite missile tests and launches. So there is a recommendation to designate space systems as critical infrastructure. It made its way into the Space Infrastructure Act that was recently introduced by a bipartisan group of lawmakers. Some have reservations because of the obvious overlap with other critical infrastructure sectors like communication or transportation or IT. But this should be seriously considered, and it's circulating through Congress again. Another critical area is stopping all future ASAT missile strikes that create debris fields. There is no binding global ban. There should be. In 2022, the U.S. pledged not to conduct ASAT tests. More than 30 countries have joined the U.S. The UN General Assembly passed a resolution encouraging states to commit to not conduct these ASAT tests. Russia and China did not support the resolution, so more work needs to be done here. Other forums have explored this. It really needs ongoing attention. There also needs to be more attention to and an international solution to space congestion management. This is a problem that will exponentially increase. Deterrence in space needs attention. Cooperation in areas like search and rescue could be something that could be built upon in these other areas. So really, there are a lot of things that have to happen even before the heliopolitical issues around the solar system internet arise. And then I would be remiss not to mention attention to cybersecurity in space and best practices for cybersecurity in space. This is an incredibly important area. There are many frameworks of these best practices. There's NASA's space security best practices. NIST has a cybersecurity framework which applies to space. There's the Cybersecurity and Infrastructure Security Agency's recommendations to space operators for improving cybersecurity. There's the DoD. There are many different compliance frameworks and ways to improve on this. So these are all areas that require attention. So going into the longer term issue, what is needed for the solar system internet? What is needed is a framework of multi-stakeholder governance for space that builds upon some of these other challenges and builds upon how the internet is currently governed on Earth. Because identifiers have to be globally unique on Earth, someone has always had to manage the distribution of these resources on the terrestrial internet. So you can imagine these include domain names, IP addresses, autonomous system numbers between networks. The solar system internet also needs unique identifiers for the addressing of nodes, for addressing data, for addressing regions, naming things, and possibly eventually network domain names in space, among others. Will ICANN do this as they do on the Earth and the ecosystem of institutions around them? A United Nations organization such as the ITU. There's already a space assigned numbers authority under the auspices of the consultative committee. So there are many things happening in this domain. There will have to be, and this is the key point, an authoritative source to maintain unique identifiers in space. So this is area one that has to be worked out. Security and other protocols will have to be architecturally different. The logic of many of the protocols on Earth extend into space, but require redesigns to accommodate some of the unique constraints and conditions that I mentioned before, and especially signal delay and disruption. Standards are underway to develop DTN, standards delay and disruption tolerant networking, as you will hear much about at this Space Summit. What body will have ultimate change control over deep space networking standards? So that is a critical question, to coordinate and to harmonize standards. Cybersecurity governance politics will be critical. So not only refraining from kinetic attacks such as ASAT tests, but negotiating about cyber restraint and a host of security questions, such as policies about when to disclose vulnerabilities that are detected, for cyber offense, for cyber defense rather, as opposed to stockpiling knowledge of these vulnerabilities to develop cyber offensive weapons. So there are many different cybersecurity questions that arise. Interconnection and access policies will be different. On the Earth, private companies that run networks make private contractual agreements to connect, either bilaterally or at internet exchange points. This has to happen in space as well. Contact plans will be necessary because objects are constantly moving. So that is very different. As this is designed, as the governance design works its way out, it is critical to build upon the systems that work on the Earth to address the architectural and political differences that exist in space, but also to learn the lessons that we've learned on terrestrial internet governance. So I just wanted to close with some insights. I'll mention a few here, and there are many more. A common numbering system, as I mentioned, is necessary for access to achieve reachability and interoperability. But because these identifiers are so crucial, they're probably going to be globally unique, finite, because they're a point of architectural control. Conflicts will likely emerge over control of these critical resources in the same way that this has been historically one of the great governance conflicts of the Earth internet. So that's one issue. The second, in my opinion, and I hope many agree, the solar system internet has to interoperate with the classical internet. So this has to be done in a way that avoids problems we've gotten into in the past with the rise of proprietary enclosure around standards, problems such as the lack of backward compatibility between IPv4 and IPv6. So interoperability is a critical issue between not just within space and the different networks, but also with the classical internet. This is not preordained. There are multiple competing standards, frameworks that will likely develop. This will be highly politicized because of the economic stakes, because of the security stakes, and especially when new nation states seek to gain some advantage. This has happened throughout the history of the internet, and it often involves tensions between multilateral and multi-stakeholder approaches. So that is something to anticipate. And then finally, infrastructure will be co-opted as a proxy for political power, just as has been the case with the Earth Internet, except we can't call this geopolitical co-opting, but heliopolitical co-opting. So these are some lessons from the Earth Internet that will extend into space. There certainly are others. I look forward to getting some feedback on this and learning more from your comments. But finally, let me just say that I'm personally excited about the efforts underway, not only around the long-term solar system internet, but also some of the moon networks that are underway and some of the satellite innovation that's happening, and including the race among tech companies. It's a very exciting area. I personally am what you call a space nut. I've seen more SpaceX launches than I can recount. I long ago witnessed a nighttime space shuttle launch. To me, the internet and space have been entangled for decades, with the most exciting changes to come. So in the same way that technology changes, so does internet governance change, and it will have to evolve to meet the space moment. Thank you so much for inviting me to speak at the Space Summit, and thank you so much for listening.